Hi guys, so in this video we're going to be starting a new unit known as polynomials. We're going to be focusing a lot on cubic functions, but also on quartics, quintics, etc. So this video we'll be learning about how to divide polynomials and also the factor and remainder theorem. So I think it's important to just start off the video by explaining what a polynomial is. So it's a function that goes with ascending or descending powers of x that are positive. So for example, let's say we have the function x squared. This is a polynomial because it's got a positive power of x. However, the function 2 over x, not a polynomial, because it can be written as 2 times x to the power of -1, and since the power is negative, it cannot be considered a polynomial. However, that is not to say that something like 3 is not a polynomial. This is a polynomial indeed, because 3 can be written as 3 times x to the power of 0, and 0 is not a negative number, so it is a polynomial. Some common things we'll be using with polynomials though is more than a quadratic. We'll be looking at cubics, quintics, quartics, etc. So like x cubed plus 3x squared plus 2x plus 1 is more like something we're going to be looking at. So let's start off with knowing about the factor theorem. So the factor theorem basically says that any value of x minus b, so if b is inserted into the function and it turns out to be 0, then x minus b is a factor. So let's just say we had x cubed plus 3x squared minus 3x minus 1. Let's say we let b equal 1. So that means we substituted f of 1 in to give us 1 cubed plus 3 times 1 squared minus 3 times 1 minus 1, which gives us 1 plus 3 minus 3 minus 1, which gives us 0. So essentially, since the value of b, which is 1, gave us 0 as an output, x minus 1, therefore, has to be a factor. And we kind of know this to be true with quadratics themselves. Sorry, that's a really bad factor. Yeah. So we kind of know this to be true with quadratics themselves. So let's say we had x squared plus 2x plus 1. We know this can be written as x plus 1 times x plus 1. And we know that since if we make any of these parts 0, it will make the entire function 0. So the way to make this 0 is by inserting -1, because -1 plus 1 is just 0. If we put -1 in there, we get -1 squared plus 2 times -1 plus 1, which gives us 1 minus 2 plus 1, which is equal to 0. So we know this with quadratics, but this is also applicable to cubics, quintics, quartics, etc. All right, and now we're going to also cover division of polynomials. And through this, we'll understand what the remainder theorem is. Okay, so let's say we had the function x to the power of 4 plus 3x squared minus 2x plus 1. So as you can see, it's a polynomial because it has positive powers of x, but it's missing an x cubed term. When we're dividing by polynomials, regardless of the fact if it's missing something, we'll have to add it in there. So that means we'll have a coefficient of 0. So we'll have 0x cubed plus 3x squared minus 2x plus 1. It's just much easier when doing division. Let's say we're dividing this by x minus 2. Now, the first thing we want to do is we want to consider, since this is 2 terms, we have to consider the first 2 terms of the polynomial. So this is an x to the power of 4 term, this is an x term. So we look at the biggest ones first. The way to get this to be an x to the power of 4 term is to multiply it by x cubed. So we're multiplying a first degree, so first degree is when it has an x to the power of 1 as its largest x term. But to get to a 4th degree, we need to multiply it by a 3rd degree. So 4th degree is obviously with the x to the power of 4 is the largest term, and x cubed is the largest term, makes it a 3rd degree term. So we'd have to multiply by x cubed in order to make it an x to the power of 4 term, or a 4th degree term. Since there's no coefficient in front of x to the power of 4 and x minus 2, that means that we just need to multiply by x cubed, nothing else. So now we do, it's a bit like long division. Now we just see what is x cubed times x minus 2. X cubed times x minus 2 gives us x to the power 4 minus 2x cubed. So we'll be subtracting that for long division. And it's a bit like considering how many times does x minus 2 go into x to the power 4 plus 0x cubed. Now all we have to do is do the subtraction, which gives us, so the x to the power 4 cancels out, which is what we wanted, and leaves us with 2x cubed. Now we bring the 3x squared down, and we consider how many times does x minus 2 go into 2x cubed plus 3x squared. So we'll look at the biggest x term in each part, and we'll see to get from x to 2x cubed, we need to multiply by 2x squared. So our next term is 2x squared. Now when we multiply 2x squared by x minus 2, we get 2x cubed minus 4x squared. So we're going to subtract from that. And when we do this, the 2x cubes cancel out as we wanted them to. Oops. And we are left with 3x squared minus 4x squared, which is just 7x squared. Now we drag the negative 2x down. And how many times does x minus 2 go into 7x squared minus 2x? Considering the biggest terms, we know that it will go in 7x times. So our next one is 7x. So 7x times x minus 2 is 7x squared minus 14x. So we're going to subtract from that. And we are left with 12x. And we bring the final term down, which is a 1. So plus 1. How many times does x minus 2 go into 12x plus 1? It goes in 12 times. Because we have x minus 2, so x to 12x is plus 12. So now that we've multiplied it by 12, we just have to subtract it now from the final one. So 12 times x minus 2 is 12x minus 24. So 12x minus 24 gives us a remainder of 1 minus 24, so that's 25. So positive 25 is our remainder after doing the final subtraction. However, it's not just, it's positive 25 over x minus 2. So what we can say is that x to the power 4 plus 3x squared minus 2x plus 1 divided by x minus 2 gives us x cubed plus 2x squared plus 7x plus 12 with the remainder of 25. If we were to write it in terms of division form, it would not be a remainder of 25, but it would be plus 25 over x minus 2. So as you can see, this process of long polynomial division is a little bit tedious, and it has room for errors with minus signs and all that, but it should give you the correct answer every time. In this case, we see that x minus 2 is not a factor of x to the power 4 plus 3x squared minus 2x plus 1, as we saw with polynomial division that the remainder is not 0, and as per the factor theorem, it has to be a remainder of 0 if it has to be considered a factor. However, we can write this using the remainder theorem. So the remainder theorem is another way of writing this, and it's basically a way of writing this in terms of what you've divided something by the divisor, times by the divisor, and with the remainder. So this would be equal to x minus 2 times x cubed plus 2x squared plus 7x plus 12 plus 25, since that's the remainder. So the remainder theorem allows you to write it in terms of the remainder, and therefore identify that this is not a factor.